Alright, let's go through some answers here. The first one, with this oil drop in the electric field, you've got a force of gravity pulling down on the oil droplet, and then since the electric field is pointed up, that means there must be some negative charge up here for the electric field lines to be going into, so that means there's some sort of attractive force pulling up, so that matches choice D. Number 2, you've got these identical charges here. What's the direction of the force on Q2 due to the other two? So Q2 is being repelled by both Q3 and Q1, but Q3 is pushing on it substantially stronger than Q1 is because it's so much closer. In fact, since Q3 is half the distance away as Q1, this is 4 times the amount of force compared to the force from Q1. So that means the net force is to the left. The electric field between two equal but opposite charges, that's going to be choice A. You've got positive on the left, negative on the right. Number 4, these two charges, since the field lines are going into L, L must be negative. They're going into R, R must be negative. That's choice A. Number 5, the relationship between the force and the distance between these charged particles is an inverse square relationship between this force and R. Inverse square. Number 6, a sphere has a net charge of 1.1 times 10 to the minus 6 coulombs. How many more electrons does it have than protons? So if your net charge is 1.1 times 10 to the minus 6 coulombs, and each electron is 1.602 times 10 to the minus 19th coulombs, negative, all you have to do is divide the total charge by the charge of each electron, and you get the number of electrons. So if you divide these two, you get 6.9 times 10 to the 12th. Number 7, two charged particles attract each other with this much force. What's the new force when one of their charges doubles? So you're looking at F equals KQ over R squared. If you double one of their charges, you've doubled the force to 0.08 newtons. If you double the distance between them, you got 2 squared, so that's 1/4 the amount of force, so 1/4 of this is 0.01 newtons. And if you both charges double, one charge changes sign, and the distance between them is cut in half. You end up with -4 over 1/4, which is -16 times the amount of force. So 16 times 0.04 is 0.64 newtons, and I would call that a repulsive force now, since one of the charges changed sign, so now instead of attracting, they're repelling. Number 8, you got two balloons with identical charges. We don't know how far apart they are if the force between them is 0.23. So 0.23 equals 9 times 10 to the 9th. 2.4 microcoulombs is 2.4 times 10 to the minus 6th. There's 2 of them, so I'm going to square it over R squared. Do your algebra. Radius is 0.474 meters apart. Number 9, the electric field lines are going to go from positive to negative. I'm just going to draw a few here. Same thing over here. We have a double negative sign on number 9. It's kind of hard to see in the printed copy. So being a double negative, I'm going to try and draw twice as many field lines on the negative on the right as there were the positive on the left. So right now there's 5 coming out of the positive. I'm going to draw 10 coming into the negative, just because it's a 2 negative. I know your copies that you guys received, it's hard to tell if it's a 2 negative, so if you just drew even number of lines, that's fine. Electric field surrounding two unlike charges, that's going to be picture A. They're going towards each other. Number 11, in a good insulator, electrons are usually tightly bound in place. That's the definition of an insulator. 12, Coulomb's law says the force between any two charges depends on the product of their charges. Q1 times Q2. 13, if you comb your hair and the comb becomes negative, that means electrons had to be given to the comb from your hair. Number 14, two point charges Q1 and Q2 are separated by a distance r. If the magnitudes of both charges are doubled, so you got 2 times 2 in the numerator, and the separation distance is also doubled. What happens to this force? 4 over 4, so nothing happens to the force. Number 15. An electron and a proton are released simultaneously from rest and start moving toward each other due to their electrostatic attraction with no other forces present. Which of the following statements are true just before they're about to collide? So I'm going to draw an electron as a little tiny negative, and a proton is big honking positive, because we know their masses are very different. A proton's about 1,000 times heavier than an electron. Now this force of attraction, I'll draw the forces as being equal. Okay, these forces are equal. But since the mass of the electron is teeny tiny, it has a big acceleration to the right. The mass of the proton is much larger, therefore its acceleration to the left is minuscule. Okay, it's proportional. So, when they meet, are they going to be closer to the initial position of the electron? Definitely not. The electron is going to have a bigger acceleration, so they're going to meet closer to the proton, which is choice C. They're not going to have the same speed because, again, the electron has a bigger acceleration. The forces they share are the same, and they would only meet at the midpoint if they were equal masses. 16. Two equal and opposite charges are a small distance apart. What choice below gives the best direction of the net force on charge Q? So I'm going to draw a few field lines here, getting ever so further up. Tangent to this field line is a line like this, and since it's positive, it's going toward the negative side, so it goes to the right. 17, an electron is going to go towards the positive end, and the positive end is down here. The negative end is here. That way the field lines go toward the negative from the positive. Therefore, our electron is going to follow path Z. The figure here shows two small charges P and Q. What do we know about them? So the charge on P is going to be smaller than the charge on Q because it has fewer field lines, so that's true. Then it says the force on P is smaller than the force on Q. That's just false. They exert the exact same amount of force on each other. So the only true statement is A. And finally, you got these two stationary charges. What can you deduce from the sketch? You can deduce that Q1 is negative because the field lines are going into it. Q2 is positive, field lines are coming out. And there are more field lines coming out of Q2 than there are going into Q1. Therefore, magnitude of Q1 is less. Good luck on the test. I should call it a quiz. Good luck on the quiz.